Thank you to the event organizers, the Magic Rain and Make It With Friends for arranging this talk, as well as the space as well. I will also give my personal thanks to the space as well for hosting us. I feel quite honored to be given this opportunity to actually share with young budding minds and maybe even other fellow game developers. Maybe you know these things already, but maybe it's a good rehash as well. All right. So let me just open the thing. So yes, this is what I'll be. Oh wait. So this is what I'll be talking about today: game programming logic fundamentals. It's a mouthful. Okay. So first things first. Oh, dang it. Introducing me, Danial Reza. So, I've been a game programmer for at least 8 years. Currently, I'm a lecturer at UOW. Yes, as you can tell, I've had some work done, you know. I'm kidding lah, that's not me lah, alright? But yes, I'm a lecturer at UOW, I'm teaching programming. And I'm also an acting coach and public speaking coach in that sense. So if you like how I present today and you want to learn how to present like me, come find me after the show. Yes, totally not shameless advertising. Okay, let's get down to business. I have to keep doing this. It's okay. Good workout. So, I'm sure I'm sure those of us who have been game programmers or aspire to be game programmers, we've had that fantasy, you know, to code like they do in the movies, your fingers typing over the keyboard like a pianist, you know, crafting a masterpiece, you know, and once you look at your code and it's clean, no error. It runs just how it should be. But reality is not that sweet. So here's the thing. Hey, lag. See, even got lag also. Wait. Okay, there you go. Why does bugs happen? Actually, bugs, they don't just suddenly appear. Okay? It's not because the computer was wrong, or this is something like a lot of us game programmers, we like to joke about. It's black magic. Suddenly out of the blue, why is this not working? It's supposed to work. No. The truth is, at the end of the day, the computer is following exactly as you code it. Whatever logic you placed, it's all based on you. So technically, the problem is not the computer, it is you, your logic, okay? But before I continue this further, just so that you get the idea of how game programming logic runs, we're gonna play a game. All right. See this marker pen? If I point, I'm not going to point yet, if I point at you with this marker pen, specifically this marker pen, you need to stand up and say a random word. Alright? This game will be in place until I say it ends. Alright? Okay, so moving forward, just being careful here not to point at anyone. Let me tell you a secret. Okay, good. You're paying attention, very good. Why you sit down? You see? First logic issue. Technically, by right, you would naturally sit down. But if you didn't tell the computer that it can sit down after it does its actions, will it sit down naturally? No. You'll just stand there and look very unnatural, correct? Okay. See, logic. So, Personally, I'm very familiar with this pain of bugs. You know, I'm very, very, very familiar with this pain. But what if I told you I figured a secret? I found a cheat code that could solve all these problems. Well, maybe not solve it completely, but it will definitely help. But before I get into the cheat code, the solution, first we have to understand what is game programming logic. So, game programming logic, how do I put this in a simple term? It's cause and effect. Basically, when you code, actually no, let's not go with code. Let's go with, you're all gamers here, right? That's why you're all here. You all play action RPGs, I assume, like maybe Black Myth Wukong or something like that, right? Okay, I hope this is still universal. If you press a space bar, what happens? Jump. Anything else? Anyone else? Nothing else? Someone say something. Yes?
Pause.
What was that?
Pause.
Pause. Okay. Interesting. Anyone else?
Interact.
You forgot the rule.
Interact with something.
Okay, good, very good. Pay attention. Remember, the game's still in play, right? Game is still in play. You're all correct. But for us programmers, it's not just a matter of just interact or jump. We actually have to break down the logic. When you jump, are you on the ground? Are you in the air? You have set conditions you need to be fulfilled before you can trigger the action. Alright? So you have to break down your thought process. So cause and effect. But in simpler terms actually, at the end of the day, right, game programming logic is systems communicating with systems. Wait, I like this one. I spend a lot of time on these slides, you can tell. To create the, oh wait, god dang it, I forgot the slides was in front. Magic. To create the magic you see on your screen. These are usually the things you don't actually get to see in terms of when you play the game. When you play the game, you won't see the code run. You only see the output. So, okay, before I continue, I want to add one more rule. Now you have to stand up, clap, and then say your random word. Okay? Moving forward. So, the cheat code. What is this cheat code?
Something that you already know.
Okay, something you already know. Okay, good. That is a random thing to say, technically. Good, very good. Everyone's still paying attention. Very good. Right, this cheat code, I should just do it like this. The cheat code is plan before you code. Wait, something's missing. On paper. Yes. Because I know it's very tempting. When it comes to coding, right, at the end of the day, coding is the exciting part. You know, when you get to feel like a hacker, you feel like that programmer. You see those words appearing on your screen with each press of the keyboard. But if you do that, if you start, maybe the first mechanic is not so bad. By the way, I'm adding one more rule. I know I already just did output, right? One more rule. Now you have to spin around. Well, sorry, clap, spin around, then say your random word. Okay? If you layer more mechanics without any reference sheet, because this paper is meant to be your reference sheet. It's supposed to be your map, so that you can keep track of everything that's happening all around. keep track of all the mechanics, so you don't end up reusing certain mechanics that you probably built at times. Because sometimes, maybe you say jump, maybe, okay, wait, that's not a good example. Let's go with speed. Let's go with a sprint. Oh wait, no. We say jump, right? But jump is equivalent to just going up. What about dash? Like the quick step. Same premise, right? Only difference, direction is different. Before this, you're jumping upwards. The force is applied upwards. With dash, or like a quick, dash, it's directed towards the direction you're moving. Same mechanic. Well, sorry, not same mechanic, but same logic, just applied differently. All right? Okay, that's fair word also. I don't know is good. All right. So, how to plan before you code? Because obviously you're not just going to keep writing your words, right? If you write words also, that doesn't really help the programming part. You still have to translate to code. So, we do it through, well, most of you, if you're an existing programmer, you probably know these terms already, but I'll just rehash it. It's called, with UML diagrams, Unified Modeling Diagrams. Okay, fair warning, this is going to be a dry topic lah. This is very, no one often uses this sometimes, because I get it. Sometimes your logic sounds simple enough. Why do you need a reference? Like I said, it's to avoid repetition by accident sometimes. Sometimes you never know what kind of perspective you'll get. But yeah, so amongst these diagrams is the use case diagram, the class diagram, the activity diagram, and not so often used but definitely helpful, sequence diagram. I won't go into detail about what each of these diagrams are, but I will go through at least a brief of it for you guys to at least understand what these diagrams represent. Alright? So the use case diagram, the what. These are basically, this tells you generally what objects are in your game. What do they generally do? Not too detailed, by the way. It's just, think of it as, let's just say you are,
Sorry?
do you remember the rule?
I just arrived.
Oh, sorry. Alright. Can someone repeat the rule? So, does anyone remember the rule? Raise your hand. Is that you? Do you know the rule? Correct. Right. Say a random word. So stand up, clap, spin.
What?
What is fine, alright? Okay. No, that's true, I didn't say sit, but it's okay. Yes, you can naturally sit, don't worry. You're not computers, right? No one here is secretly an AI, right? Just making sure. Okay. So it's a high-level blueprint of your game. Think of it as like when you are meeting a friend in a coffee shop. Do you immediately tell him your entire architecture of your game? Like you go down to the very detail, down to the code, everything. No, right? No, right? Usually when you're meeting with a friend, you got an idea for a game. What does it start with? The conversation? Dude, I got an idea. There's a guy, yeah, and he does this. And there's enemies. It's just a high-level description. This is usually how people start their conversation with the idea. This is just to get you the idea of your, this is just to get the general picture of your idea, right? I also have an example for it. Okay, wait. So yeah, the goal is to define the boundaries of your game. So I've already mentioned, oh, it's a guy that does something. Let's just go a bit more detailed, like, oh, it's an action RPG. You can attack, you can dash, you can jump, you can ride horses. Yes, I just described Elden Ring. But in this case, our example is going to be, wait, can you see this one? Can everyone read this actually? Okay, so basically I'm using our current game as the example. So you got the system, me, the player, you guys are the players. Let's have someone else. Remember the rule? Yep, correct. Random word. Okay, yeah, that's fair, but cannot be used already, yeah, guys? But yes, you see, it's a high-level overview of what's happening here. You got your player. What do you guys do? You can ask questions. Well, not now, okay? But yes, you have an ability to do after this. You can listen to the talk. You can also wait for the marker to point at you. That's also defining the triggers, correct? Then on my side, I have changed the rules like I've been doing so far. I give the talk, I point the marker, and I answer questions. Of course, I say after this. But I would like to turn your attention towards here. So just now I mentioned wait for the marker to point at you, right? Then once the thing is pointed towards you, you say a random word, and then you clap. Okay, that's a wrong order. Oh wait, no, wrong. Sadly, this one you cannot see the detail. It says include. This means if something is include, that means it has to be done what? Anyone want to take a guess? What does it mean if it's included with the action? Don't worry, I won't use the marker pen. Anyone want to take a guess? What does it mean if it's included? Oh, so I said here, this one says random word. And over here, the relationship between this and clap is it's included. What does it mean? Correct. It's included in the action. So you see, with UML diagrams, you're describing your systems in the form of pictures. I mentioned before, you can easily write, yes. But be honest with me, how many of you will read the walls of text on your WhatsApp? If it's instructions. Maybe if it's your job, yes, you have to, definitely. But it takes a lot to process because you actually have to go through the words and find the keywords, correct? Especially when it comes to searching through information through walls of text. This is a lot more straightforward to communicate your ideas. All right? Next, we have class diagram. Now we talk about the who. Who is inside your system? What objects are inside your system? But this time we go more detailed. This is where we start seeing the general structure of your code. For programmers, you know when you have if you want to specify an attribute, you want to initiate an attribute, you have to call it first. Okay, I've got an example here, don't worry. But yes, it's to organize your data and behavior. As much as I say it's system, game programming logic is system communicating with system, it's also transference of data. It's information being transferred about. All right? So in our example, this is a class diagram. You can generally see the structure of your code already from here. So you got your audience, you got your name. Everyone has a name, right? Yes? Everyone has an age. Everyone has your random word that you're going to say when it's pointed towards you. And you also have a pointed, like your triggers. When can you only start triggering your thing? You have to make sure you are pointed, correct? Then you have your actions that you can do. You say the word, your stand, your ask questions. But I would like to turn your attention towards, then cannot see. If you can see after this, this is a dash and this is a plus. So what they represent in programming is private and public. Okay, let me put it into this context, okay? Private means anybody outside of this object cannot access. So they cannot see this information. They cannot directly call it. Okay? Public means everyone can access. Technically, everyone should be able to access, or at least you should be able to access your actions. That's fine. But no one should have access to your bank accounts or how much money you have in there. Unless you want to, but you don't have to. For your security reasons, you don't. You don't want anyone else to know these details. But you can see, you are beginning to see the structure of your code now. You've got your attributes, the data that you're going to use in your formula, in your mechanics. So far, everyone's following? Okay, good. Next one. The activity diagram. This is where the logic comes into play. This is basically just to tell you your flow of logic. What is supposed to happen, what first. In terms of the system, it's basically the translation of how the system runs. Okay? It's easier to go into example. But yes, this is your logic map. Sorry. This is your logic map. The goal is to visualize your decisions, your possible options that maybe your objects needs to have. So in this case, this is your logic map. You don't have anything, you're not doing anything for now. You wait for the marker to point at you, and then you think of your word first. Once the marker has been pointed towards you, you think about the word first, right? No one just randomly say, right? You think of the word first, then it splits. You could have directly say the word, which is our first rule, right? Or you can clap your hands, which is the next rule I introduced. So far, you're following? Okay, but yes, so this is an activity diagram. This is just to break down what thought process your object or system needs to go through before the final output, before you can see the magic happens. All right? And the last one, sequence diagram. Okay, I mentioned not always you will use this one, but this is one of the important diagrams you need to include as well. This tells you when things should happen, at least the order of things. So this measures basically the timeline of the systems communicating with one another. Okay, this one I couldn't use our game for the example because it's way too simple. You wouldn't be able to see the general order. Even if you have an order, it's just me and you. You don't see it in an overarching system where you have many more elements to take into account. So I used a different example for this one, just so that you can see. I also cannot see. Wait. So the first one says customer. The customer logs into the login screen, goes into the login screen, and then it goes to the security management with the user to just double check if the user is validated, and so on and so forth, before the message finally goes all the way back to the user. That's how you should be looking at your game programming logic. But do you notice something? We have not touched all the for loops, int, or even the if statements. But can you begin to see the structure of your code already? Correct? So, things to take note. We tend to forget because computers always create, when we code and when they run the things, right, it's always instantaneous. We always tend to forget this simple fact. The computer is not smart. It's a very good student. It'll follow your logic through and through. It'll follow it perfectly to the letter. But it will not know the difference between, like just now, remember my first example? I asked you to, if I point at you, you will have to stand up and say the word, right? You naturally know when to sit down. A computer does not know that. Or in a much more wackier case, if you go over the ledge, if you don't establish that there's gravity, the computer will not know that gravity exists. The thing to take note here is you got to treat your computer, you got to treat the program, the computer, like you're trying to describe every single step to it. You have to be as detailed as possible, as thorough as possible. If you want it to work exactly as you need it to, you need to be more thorough. Break down the steps. Like if we put this into example, I move my marker pen, point it towards the target. Sorry. Could you run the game? Thank you. Oh, no, I'm pointing at you. What do you have to do? Can someone remind him the rules? Correct. Stand up, spin, clap, and say a random word. Yes. We break down the steps, you see, in that logic. Technically, by right, if I don't explain the logic, I just point. Computer. You only see that output. So this is game programming logic. It's just breaking down the steps that happens in the system that's supposed to happen, but because at the end of the day, the computer reads things almost instantaneously. That's why you don't see it like take a while to process. But yeah, things to keep in mind. Always describe to it in thorough steps. Break down your steps. Break down your thought process. All right? And that's it. That's game programming logic. Any questions? How many more minutes?
Time is enough. Wow. Still have about 30 minutes.
Wow. It's fine. We'll use it for questioning, I think. So it's okay. It means more time for you guys to ask questions. Do you guys have any questions so far?
No questions? Or everyone to shut the eyes?
I like to say this in my class. My students know this question. I always say, ask your questions. Don't care whether it makes you seem whatever it is. What's important is if you don't know, if you don't ask, then what happens? You don't know. You still maintain you don't know. But if you do ask, at least, even if people make fun of you, what's important is you know now. That's a habit I think we should all actually keep carrying forward. Don't care. Be curious. Alright? Yes?
So in terms of documenting all the diagrams, let's say you map out everything, right? How do you practically keep track of it, and how do you share it with the organization?
We have this thing called a GTD, a game technical document. You collect it in one documentation. So basically your workflow process, you pick, let's just say you have to work on a specific mechanic. You only look for the parts that is important to you first, then you start writing the code. That should be the workflow process. Every time you refer back to the diagram so that everyone keeps track of it.
So just one single document.
One single document. And of course, an Excel sheet to keep track of the progression of each system. Otherwise, someone starts working on something you don't know, then you end up working on the same thing, then you suddenly have an overlap. Or maybe you have a GitHub conflict file.
That industry, we use GitHub to manage crash, get the code at one point. So, what do game developer control the like version control.
I think a lot of the game developers here have a lot of things to say about that, right? But version control, usually our usual standard at the end of the day, I've seen many versions of it. I've had people instead of having to, use the GitHub, they would actually they'll just remake whatever you made and then put it in their own system manually code it. I'm sure you've all been through that, right? When you didn't want to deal with GitHub, right? Sorry, maybe not GitHub, maybe because it's Stencil. You guys know Stencil? It's a drag and drop, it's a block-based kind of programming. And there's no way to actually combine the files other than, you actually have to just manually remake the code. Yeah. But in terms of practice, right, what we usually do is always make it a point. Someone updates something, straight away pull. Make sure everyone's version is constantly updated before you start work. Before you push anything, always pull. That comes from experience. Okay. Any other questions?
Like I said, it's not the presentation.
Sorry?
I came in late.
Oh, okay.
Ask for a recap later.
You can ask for.
We will be posting up this talk later. So for those who came late, the talk will be on YouTube maybe by next week-ish. Okay?
Oh, I actually forgot one part of my line there. Yeah, I tried to rehearse this, but basically one of the cheat code I wanted to say was, it's not AI, just to let you know. But I use it in a way that I don't think you might use it. What I usually use AI for, technically for LLM, I will just ask it to go and check my code. So the main provider should always be you. Don't ever trust the LLM to code the thing. Sometimes that's the trick to it. It looks right. But maybe in the long run, it might cause you trouble, at least in terms of scalability. Because you have to bear in mind, whatever it does, whatever code it produces is based on its own database. It's not generally smart, it's just matching patterns that this looks right. All right? So I always use it to just double check in terms of pattern, like, do you spot anything that could possibly cause a crash? Or do you see any possible way that my code right now there are gaps in its logic? I use it like a second person to just double check. Okay? But yeah, that's all. Any questions? Let's just use up the whole time. Yes?
At what point does making diagrams like this cost being effective? Because like at some point, when students like pick code base, like it's gonna be like spaghetti everywhere.
Sorry?
Making like diagrams. Because like I can't make diagrams of my code base, like everything starts becoming a spaghetti once it reaches like a certain point.
Everything starts becoming what? Sorry? Spaghetti. I see. Okay. Technically, the spaghetti is, you're supposed to do all these diagrams before you get started on the code. Because sometimes when you start working alongside, when you start trying to create the diagrams alongside maybe an existing project, you've already got like most of it mapped out, right? You're adding more stuff into it. You're trying to justify your previous legacy code, like any code before this, but it might not be optimized for your architecture. The point of the diagrams actually, to be exact, can I actually direct this back? Oh, I can. If you go to the class diagram, this is actually where you'll start seeing like redundancy, or maybe your architecture is not as optimized. You use this thing, I haven't touched it actually, I didn't touch it in this one, but technically what you want to look at is design patterns. So design patterns, they make your architecture a lot more robust and it makes it more efficient, because at the end of the day, okay, for me, right, this is my personal mantra as a programmer. When you write the code, you have to think, is this gonna make my life easier tomorrow? Not today. Because sometimes it solves your issue today. Then maybe a week later you revisit it and then you realize, oh shoot, it causes problems. The point of the class diagram like this is for to get you an overview of your architecture before it becomes the spaghetti code. Just things to keep in mind. Anyone else?
They say optimization is the devil.
Optimization is the devil?
Yeah.
So, actually there's another thing. I say a lot of things in class, didn't I? What I like to say in class actually, I know the usual memes with programmers. If it works, don't touch. Oh, you see? See? Everyone knows that rule. Everyone knows that rule. But I always like to add one more rule there. This is definitely true if you're on a time-sensitive kind of situation. You have to ship it. You have to that one. No choice. But if you've got time, optimize it. Really try to think how can you make your life easier. Because this is not just a matter of making your life easier tomorrow. It's also future you. Honestly, always code with future you in mind. That's how you should work. Because maybe I've seen some people actually actively say this, that's a me tomorrow's problem. And then you tomorrow is going, curse you past me. Why did you do this? So to answer your question, yes, it is the devil when it comes to time-sensitive things. But when you can, you should try to optimize your architecture. Because optimizing it means in the long run, it's more easier to maintain and easier to scale. That's the important part. Actually, that's the ideal we want to get to in terms of programming. We want to be able to scale our code. That means like we talked about the spaghetti code, right? Adding features. If your architecture doesn't support like adding new features, or if you need to add a feature and you need to change like 50 things, then it is not optimized. Your architecture is not optimized. But yeah, this one comes with experience. I know I mentioned before, like you want to be able to be like those movie programmers, you know, your fingers type over the keys like a pianist and you craft perfect code without having to look at the document. But maybe in the future, when you gain more experience, yes, maybe you'll get to that point. But till then, break down your thought process. It makes a big difference actually. Think things in step by step. Step 1-2Legend, right? Okay. Any other questions?
Even this counts as a process in game development, right?
Exactly, it is.
So, but what if I just make a game and it works fine and all, but then does it actually matter if I have that or not?
Okay. No, it's true. I think this actually goes back to his question, where he said like, there are times where it gets too spaghetti, it seems a bit redundant to like have this documentation. Yes, if your game is very simple, fine, it's okay. But think of it this way. We talked about scalability, right? Let's talk about, let's just say, whatever you come up with is a prototype. It's just the baseline. You haven't added new features. And technically, maybe you started the project as just you as the programmer. Now, if I add in another programmer, a complete new guy who has no idea about the project, what will he have to do to understand your project? He has to, well, if no documents, remember? If there's no documents, what does he have to do? Reverse engineer. How long does it take for you to reverse engineer the whole project? If it's a simple project, okay. If it's not, if let's just say the project has been in development for 2 years, how long do you think it'll take you? quite a while. That's why this is the other reason why the documentation is important. It's not just for the fact of making sure you don't make redundant systems. It's also so that when you bring in new people, they don't have to try to break down your entire 2-year worth of project to understand your project. You can just simply hand them this documentation. Because from here, you can already immediately tell what objects you have, what's the structure of the code, what order does it need to go to run, to do the magic you see in your screen. Does that answer the question? Yeah, no worries. I love this crowd, always asking questions. Any other questions?
So like you talked about how to like do the document stuff, but like at what point, like for example, like would it be like a good time to start working on like the action coding? Because like it's good to plan out.
Yes.
But like what is the balance between like planning and like doing to see whether you actually work?
Okay. So actually, technically, if you can, right? Workflow wise, so I've mentioned doing the documentation and then run the code, right? So let's just say, let's use the example of a 2-year project. They already have documentation already. But let's just say you have to come up with something completely new now. So you have to look at the overarching architecture. You plan out your project first, your idea first, see if it sits well with the project, and then you run your code. But okay, this is more for an existing project. Let's just say you're starting from scratch. Then take it step by step. If let's just say you want to start with you just want a simple movement mechanic, then you write that out. Don't have to plan out the whole entire thing. At least start documenting your thought process. Because then it's easier to look back. That's the other reason also. I say new people, new programmers, but in reality it's also for you. Let's just say you left this project 2 years ago, and now you have to revisit it. Will you remember what you coded 2 years ago? No, you will not. This is a easier transfer process in terms of information. So you'll look at the document, then fix it as you go. But yeah, you should be updating the document as you go. Okay, just because you start, that doesn't mean that's the end product. Don't treat the documentation as a homework you have to do. Treat it like a map that you're crafting to navigate your systems. Make sense? Yes.
You mentioned how you were treated as a map for the system. But then if I do this, I can imagine myself planning, adding features until the game will be one.
That's true. That's true.
So when should I actually start creating things instead of planning?
Technically, you can already start when you see the structure of the code, right? You can straight away start coding already, technically. Because you're already at this point, you can already plan out what kind of attributes you're going to use, what functions you'll possibly have, what relationship. Okay, I didn't touch on relationship, but that's an entire different topic entirely. But the minute you already have like a general framework, you can already get started actually. For me personally, what I would like to go with is, if you figure out the core of your game, like let's just say your game is a platformer, you straight away map out the logics that are always present in all platformers. Jump, move, etc. That one you can immediately get started on coding. The rest, the added features, that one can depend on your designer lah. If they have an idea, like they got a unique idea they want to add into the game, then they start adding it on top of your architecture there. But at that point, you see, you already got the baseline already. It's a lot faster now, right? Rather than you start from the scratch. So I guess for me, it's just if you get the baseline of your game itself, get started already. That's good enough already. You don't have to plan until like completely perfect. No one can do that. Yeah. Does that answer the question? All right. Anyone else? Any other questions? Got a question? No? Okay, it's all right.
Last question. You prefer which engine? Unity or?
Choose wisely. Choose wisely. Just go stencil. No, I'm kidding lah. No stencil. No, I freaking hate stencil. Sorry. It's a good, don't get me wrong, stencil's a good way to get started, to get the idea of programming. But whether is it a thing you can use to scale a full-on project, not so. Personally, I will go with any engine that allows me to at least code manually rather than anything that's block-based. Only because I can structure the architecture more, more thoroughly lah. Because if your architecture is good, it's very easy to update your games. Like you want to add new feature, it doesn't take you like maybe months to go and break down your game and then rebuild it again with new features. It should just be plug and play. That is the ideal standard in terms of adding features. All right? Any other questions? Oh.
Would you recommend to share games?
Oh, to share games. I think this one's more of a different kind of. This is a publishing question actually, but.
Are you talking about sharing the final game or the source of the game? Final game.
Yeah, then it's a publisher. This is a publisher question. Sorry. Today I'm only a programming teacher, speaker for today. Yeah. But we maybe you could meet the other. I know there are a few developers out here, around here. You can ask them after this. But I think it's a good question technically, because I'm sure they all have their own You all have your own respective experience with it. Okay. Any other questions? That's not publishing related, tech related, if possible.
So personally, I'm from a programmer, but I'm a designer background. And I was curious, what are some tips that you would suggest when it comes to communicating from a programmer to anyone else in the team?
This is very fitting because I am like, this is something I also talk about a lot. Okay, personally for designers, right? I think if you get an idea of these diagrams, because I'm pretty sure you guys don't usually touch these diagrams, right? But if you can touch these diagrams, right, it's easier for you to communicate directly with your programmer. Because I'm not saying you should straight away start coding out start writing out the entire logic. But at least if you understand how your programmer needs to process the information, it makes it faster, the translation, the communication with the programmer. So it also comes down to like knowing the limitations of the engine. That kind of helps. That's pretty much it actually. If you study these diagrams, actually, it's a good head start actually. Because it gives you an idea, a picture of how the programmer needs to process the information before they translate it into code. It's a lot more effective than just saying, I want this guy to jump. Makes sense, right? Yeah. Anyone else? Oh.
Maybe this is more of a design question, but like games that try to imitate or represent any kind of system that exists in the real world, is there a rule of thumb for some level of abstraction or granularity that is sufficient for that to serve as a mechanic in the game?
Okay. Let me try to digest your question because it is a pretty big question. So what you're trying to say is, what if your game is sort of like using a mechanic that's already existing in another game? Is it?
Okay, I don't know. Like Victoria 3 represents the economy and trade in the world.
Oh! Now we're talking about philosophical now at this point. Is it?
I don't know. You can take it wherever.
No, actually, this is actually quite fitting to what I've done. Okay, this one I'm going to go a bit of a tangent a bit. So for my experience, I like to craft games revolving around psychological stuff. one of my games actually that I'm still actively developing is basically a meditation game. But the idea is to basically reflect anxiety and overcoming anxiety. But through code, what I do is actually I just take microphone input, and then based on the timeline, as long as the sound reaches a certain threshold, it will fill up the meter to activate the ability. At the same time, yeah, it's just a matter of logic. In terms of logic flow, basically it will be like, what stance am I at when I activate my ability? For example, like that. So I guess you could say the granular, how descriptive you need to be in order to reflect a certain sorry, not psychology, that's not the right word. What's the word I'm looking for? No, it's not system. Philosophy that you're trying to, like for example, you said like it's an economy thing, right? Yeah, you have to translate it in terms of logic and mathematics in this case. So in like my case, I said I take the microphone input, for example. Yeah. Does that help? I hope, because your question is a pretty broad topic, but I'll try to answer at least within my capabilities. But does it help?
Yeah, somewhat.
Okay, it's okay. All right. Any other questions?
No? No one else? Yes?
Did we go beyond time?
No, I mean, we still got time actually.
Oh.
If anything, what we will do is we will end the talk session now. You'll still be around, right?
Because I'll be here until, since you said 4:30 actually.
Yeah.
Yeah, until 4:30.
So, yeah, so we'll end the talk session now. So, any announcements you want to say?
Thank you everyone for making the time to come today. I hope whatever I share will help you in your journey as game developers. Even if it doesn't, it's fine. It's okay. What matters is, what can you get from this? If anything, you can also connect with all the people around you. That's also a good thing, you know. I hope you enjoyed the game. Thank you, everyone.